So this is a classic chicken and egg problem. That without robots, we can't develop useful apps. And without useful apps for the robots to run, there's no robots. So the question is, so that's why we don't have any. And so my last thing is, how are we going to make this happen? How are we going to make this happen? Well, first, we cannot do this alone. Actually, we don't want to do this alone. Because it's more fun to do it with other people. And so what we are doing, our strategy, is actually create a community of people, of researchers, developers, and industry, and get them to work together to make this a market and a real thing. And what we're bringing to the table is that we're bringing a platform, a sturdy, robust platform for these guys to stand upon and to build upon, and so that software guys can work on the software things, the hardware guys can work on the little hardware things, and the researchers can stand up really high and do all the really hard stuff. And this is our strategy, is to build this platform, and then you're going to see it in a little bit. It includes a bunch of things. And the most important thing I want to say is that we, as Willow Garage, we don't intend to own this. We don't intend to control it, and we don't intend to be the gatekeepers or the app approvers of this system. We don't intend to slow it down. We want to accelerate this. We want to put the pedal to the metal and make this happen. Because I'm not getting any younger. I want to make this happen in my lifetime. So this is why I started Willow Garage, and this is the vision of the company, to make robots happen and make this an industry. So I answered my little questions that I set up for myself, and I just want to tell you a little bit about how we started. Steve and I got together and we started working and doing all these different things. We did little projects. And one day Steve said, "Hey, why don't you go over to Stanford? I want to show you something." And we go over to Stanford, and I was like, "Wow, I haven't been to Stanford in a while." And these two little kids, or these two grad students, showed me their little wooden robot they built. It was absolutely, I was enthralled. It was able to clean up a room, pick up all the different things. And I was like, great, I have kids, perfect. It was able to slice a cucumber, hold a knife and slice a cucumber. It was able to feed somebody, an elderly person, oh wait, that was Keenan, some food by itself. And I was like, this is great. So, and what was most impressive is that they actually they had this vision of doing this, building some robots. And they basically told me that it takes about 9 months to build these robots. And I was like, great, perfect. My woman we have a baby in the cooker. Let's race. and sure enough, 2.5 years later, and 2 kids later, we're here today in this wonderful tent. And it's not raining. And so, without further ado, I'd like to have these 2 graduate students, or not graduate students anymore, come with their team and show you what we've been working on and how this is going to change the world. So, I'd like to introduce you, Eric and Keenan. Thank you.
This all started for Eric and I 5 years ago when we were starting our PhD program at Stanford in robotics. And we started where a lot of people start, by saying, all right, let's go get a robot and then do something new with it. And we went to buy the robot, but you just couldn't get the robot. So we made our PhD project about that robot. A robot that someone could just get and develop new things on top of. We firmly believe that that missing platform, the platform that turns what's today a hardware problem into a software problem, is the missing ingredient holding the community back from building the personal robotics industry that Scott laid out.
What we're doing here is building that missing platform. There are two parts to the solution. One is the hardware, which is the PR2 robot, and the other half is the software platform. ROS stands for Robot Operating System. Our vision for ROS is for it to become the Linux of robotics, a free, open source platform for people to build on, a platform for both researchers and industry, to support innovation and to support commercialization, and building real companies on top of it. In the design of ROS, we put a lot of focus into lowering the barriers to entry so we can build a bigger community. You can write code in whatever language you want to, it's easy to integrate existing software, and it's easy to run ROS across many different hardware platforms, not just the PR2. ROS is currently running on dozens of robots, including some that we've never seen before, in institutions all over the world. Many of those same institutions are taking the ROS code and releasing it open source. There are 24 different institutions that right now are putting code online that you can go download, build on top of, either build your research on top of, or build a company on top of. Due to this adoption by the community, we've recently passed the milestone of having 1,000 different packages, pieces of software that somebody can take and use independently on a different robot in the ROS ecosystem, which we're really excited about. This adoption has been faster than we ever imagined it would be, and we think that it really demonstrates that ROS is meeting the need the community feels for a common platform everyone can build on top of.
So ROS provides the software. Don't worry, he'll talk. ROS provides the software side of that platform and provides a great development environment for developing new robotic capabilities. We've also have hardware, the hardware side of that development platform, which we believe is vital to completing the puzzle so we can really turn this into a software problem going forward. So now we have that robot and we'd like to show it to you. Introducing PR2. Designed from the ground up to enable software developers to focus on new ideas and new technologies. It integrates all of the essential capabilities you need, including capable arms, powerful onboard computing platform, sensors in the head, body, and even cameras in the forearm, and of course, it runs ROS. All these capabilities let you as a developer do new things out of the box. We are very proud of PR2, as you can tell. And we're very excited about the potential applications that people have been coming to us with for a platform like this. Applications in the home, applications enabling independence for those with disabilities and aging populations. Industrial applications, including pick and pack, including stocking grocery store shelves, and even light assembly work. Before we move ahead, we want to do a couple thank yous and acknowledgements. So first of all, we want to thank